Hello friends, this video on visualizing shapes part 8 is brought to you by examfear.com. No more fear from exam. Now in polyhedrons also we have different categories like regular, irregular polyhedrons, concave, convex polyhedrons. So let's start with regular polyhedrons. The word regular, what does it mean? Regularity means equal. So a polyhedron is said to be regular if its faces are made up of regular polygons. Now do you remember what are regular polygons? These are those polygons where all sides are equal and all angles are equal. For example, equilateral triangle, square, these are examples of regular polygons. So do you think that you can also have polyhedrons which are made up of regular polygons? Yes, it is quite possible. So if you take the example of a cube, so the cube is made up of squares and squares are regular polygons. So cube is a regular polyhedron. But this is not the only criteria for a polyhedron to be regular. This is just one criteria, that it should be made up of regular polygons. So this is our criteria number 1. What is the criteria number 2? Criteria number 2 is that same number of faces should meet at each vertex. This is criteria number 2. That means, let's think of this cube. So think of any vertex. Let's say I am assuming this vertex. So how many faces or how many edges? So if you look at this point, how many faces share this vertex? So if you see the top face, the side face and the front face. So 3 faces share this vertex. So every vertex should be shared by 3 faces. So here you take this vertex. So this vertex is shared by the side face, the bottom face and the front face. So in this fashion, the second criteria is that in a regular polyhedron, each vertex should be shared by same number of faces. So let's take this example. What is this? This is a triangular pyramid. So this is also a pyramid, but it is triangular pyramid because the base is a triangle. So let's say this is the base, and from the base you have 3 triangles. This is one triangle, this is second triangle, and the back side one is the third triangle. So these 3 triangles, they rise up and meet at one point, and that's how they make a triangular pyramid. So in this triangular pyramid, if you see each of the faces, so how many total faces are there in this triangular pyramid? There are 4 faces, and let's say that each face is an equilateral triangle. So let's assume that each face is equilateral triangle. So that means the faces are made up of regular polygons. So this should be a regular polyhedron. Right? But let's also look at the second criteria. Second criteria says that at each vertex, same number of faces must meet. So let's consider this vertex. So this vertex is shared by how many faces? The front, this triangle, right? So the back side triangle and the base triangle. So 3 faces meet at this point. Similarly, at this point, all the 3 triangles which is going up. So all the 3 triangles meet here. So that means in this case, 3 triangles or 3 faces meet at each vertex. So it satisfies both the criteria and therefore it is a regular polyhedron. Let's look at the third example, which is a octahedron. Octahedron means, octa means 8. So this is a polyhedron with 8 faces. So total this figure has 8 faces. And what are each of those faces? Each face is a triangle. So if you see, this is one face, a triangle. This is another face. This one is yet another face. This is yet another face. And similarly, you have 4 such triangular faces in the downward direction. So you have a total of 8 triangular faces, and each triangle is an equilateral triangle, which is a regular polygon. Therefore, this is a regular polyhedron. What about the second criteria? So if you look at any vertex, for example, this vertex, how many triangles meet? Triangle number 1, triangle number 2, triangle number 3, and triangle number 4. So 4 triangles meet at this vertex. Similarly, let's think of this point. So here how many triangles meet? Triangle number 1, triangle number 2, triangle number 3 and triangle number 4. So here also 4 triangles meet at a point. So here we see that 4 faces meet at each vertex. So both the criteria are satisfied, and therefore this is also a regular polyhedron. So the name of this regular polyhedron is octahedron. That means a polyhedron with 8 faces. And what was this? This was a triangular pyramid. Now what about the irregular polyhedrons? Let's look at their examples. Now when any of those two criteria is not met, then the polyhedron is an irregular polyhedron. So here on the screen we have some figures. So let's find out which one is an irregular polyhedron and why. So let's start with a cuboid. So in case of a cuboid, the first criteria fails. Why? Because it is not made up of regular polygons. Rectangle is not a regular polygon. So rectangle is an irregular polygon. So therefore, this polyhedron is an irregular polyhedron. So the first criteria failed here. Let's look at the second example where we look at this pyramid. So this pyramid has a quadrilateral base and 3 triangles. So when you look at the quadrilateral, this is not a regular polygon. So therefore in this case also the first criteria fails because it is not made up of regular polygons. Third, let's talk about the cylinder. So in case of a cylinder, it is not even a polyhedron because it is made up of curved surface. So this cylinder is not a polyhedron at all. So since it is not a polyhedron, there is no point talking about whether it is regular or irregular. Fourth example, let's think of the hexahedron. What is hexahedron? Hexa means 6. So it is a polyhedron with 6 faces. So here each face is a triangular face. So it has 6 triangular faces. So in this case, each of these triangle might be an equilateral triangle. So that means the first criteria might get satisfied. But what about the second criteria? So will that get satisfied? So let's analyze hexahedron in more detail. So let's analyze why is this hexahedron an irregular polygon. So let's see. So here on the screen, I have shown very distinctly what are the 6 triangular faces of this polyhedron. So if you look at the first diagram, so this gray triangle is one face, this gray triangle is the second face, and this total gray triangle which is on the back side is the third face. Similarly, below, this is the fourth face, this is the fifth face, and this entire thing towards the back is the sixth face. So that's how there are 6 faces in this triangle. But still, it is not regular. Why is it not a regular polyhedron? That's because the second criteria is not met. So if you look at the second criteria, let's analyze the total number of faces that meet at a point. So let's mark this point as A and let's mark this vertex as B. So let's see that how many faces meet at vertex A. So at vertex A, faces 1, 2 and 3. So all of these meet at the vertex A. So that means a total of 3 faces meet at vertex A. What happens at vertex B? So at vertex B, the triangles 1, 4, because 4 also meets at point B, and 6. So 6 also meets at point B. So can you think of any other face which meets at point B? Yes. Face number 3 also meets at point B. So basically at vertex A, the triangles 1, 2 and 3 meet, whereas at vertex B, the triangles 1, 4, 6 and 3. So all of these meet. So that means how many faces meet? 4 faces meet at point B. So do we have the same number of faces meeting at each vertex? No. So that means the second criteria has failed, and therefore this is an irregular polyhedron. So wherever you come across a polyhedron where you are not very sure if each face is a regular polygon or not, then you also need to make sure that the second criteria is meeting or not. So So it is very, very important that both the criteria is met for a polyhedron to be a regular polyhedron. Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.